Our universe is always moving. From the smallest atom to the largest star, everything is in a constant state of motion and change. But what is it that causes these movements? What powers the sun to shine and the wind to blow? The answer lies in the fundamental concepts of physics, force, energy, work, and power. In this journey through the cosmos of physics, we will explore these concepts in a way that is easy to understand, even if you're a beginner. We will uncover the invisible forces that shape our world, the energy that fuels our lives, and the power of physics to explain the universe around us. Get ready to embark on an exciting adventure into the fascinating world of physics, where we'll unravel the mysteries of force, energy, work, and power. Join me, and together let's explore the universe in motion. Force is what makes things move or stop moving. It's a push or a pull that can change the motion of an object. Imagine a game of tug-of-war. Each team is pulling the rope, applying force. The team that applies more force will win the game. Forces are everywhere. When you kick a ball, you are applying force to it. When you lift a book, you are applying force against gravity. Even when you are sitting still, forces are acting upon you, keeping you balanced in your chair. Forces can be strong or weak, and they can act in different directions. Understanding force is crucial to understanding how the universe works, from the orbits of planets to the collisions of atoms. Force is the invisible hand that sets the universe in motion. Energy is the ability to do work. It is the fuel that powers everything around us. Without energy, nothing would move, nothing would change. Energy exists in many different forms. Heat is energy, light is energy, sound is energy. Even a moving object possesses energy, which we call kinetic energy. Think of energy like the money you use to buy things. You can use money to buy food, clothes, or a ticket to a movie. Similarly, energy can be used to do work, like moving an object, heating a room, or lighting a lamp. Energy is the lifeblood of the universe, driving all motion and change. Kinetic energy is the energy of motion. Anything that moves has kinetic energy. The faster something moves, the more kinetic energy it has. A speeding car has a lot of kinetic energy. A slow-moving bicycle has less. A parked car has no kinetic energy at all. Kinetic energy is all around us. The wind we feel on our face is kinetic energy. The waves crashing on the shore possess kinetic energy. Even the air we breathe is made up of molecules with kinetic energy. Kinetic energy is the energy of motion, driving the dynamic processes of the universe. Section 5. Stored energy, potential energy. Potential energy is stored energy. It is the energy an object has due to its position or state. An object high up has more potential energy than an object on the ground. A stretched rubber band has potential energy. Even a battery has potential energy stored inside it. Imagine a roller coaster at the top of a hill. It is not moving, but it has a lot of potential energy due to its height. As the roller coaster goes down the hill, its potential energy is converted into kinetic energy. Potential energy is everywhere. A book on a shelf has potential energy. Food we eat contains potential energy. Even the water behind a dam has potential energy. Potential energy represents the possibility of motion, waiting to be unleashed. Section 6. The work of physics. In physics, work has a specific meaning. Work is done when a force causes an object to move a certain distance. In other words, work is the transfer of energy from one object to another. Lifting a heavy box requires work. Pushing a car requires work. Even walking requires work because you are using force to move your body. It's important to remember that in physics, simply applying force without movement is not considered work. Holding a heavy object still may be tiring, but no work is being done in the physics sense. Work is the manifestation of energy transfer, resulting in a change in an object's motion or state. Section 7. The power of force and time. Power is the rate at which work is done. It tells us how quickly energy is being transferred or transformed. A powerful machine can do a lot of work in a short amount of time. A car engine has more power than a bicycle because it can do more work, like move a heavier object, in the same amount of time. A light bulb's wattage tells you its power, or how much electrical energy it uses per second. Power is an important concept in many areas of physics and engineering. We use it to describe everything from the output of engines to the brightness of stars. Power is the measure of how quickly work can be accomplished, highlighting the relationship between energy, time, and the forces at play. Section 8. The interconnected web of physics. Force, energy, work, and power are not separate concepts. They are all interconnected like threads in a web. Force can be used to do work, which involves the transfer of energy. Power tells us how quickly this work is done. Understanding one concept helps us understand the others. For example, if we know the force applied to an object and the distance it moves, we can calculate the work done. If we know the work done and the time it took to do it, we can calculate the power. These concepts are fundamental to our understanding of the universe. They explain how stars shine, how planets orbit, and how life on Earth is possible. The interconnectedness of these concepts reveals the elegance and unity of the laws governing the physical world. Section 9. The importance of physics in our lives. Physics may seem like a complex subject, but its principles are at work all around us every day. Understanding force, energy, work, and power helps us to design and build better machines, from cars to computers. Develop new sources of energy like solar and wind power. Understand the natural world, from the weather to the stars. Make informed decisions about our energy use and its impact on the environment. Even simple tasks, like riding a bike or throwing a ball, become more interesting when we understand the physics involved. Physics is not just about equations and formulas, it's about understanding the fundamental principles that govern our universe and our lives. By grasping these concepts, we gain a deeper appreciation for the intricate workings of our world and our place within it.